Okay, let's write this down. So we have a gain here on a $3,700. We're gaining 678. All right. The principal is equal to 3,700. Okay. The next thing, I'm going to put down the time, and the time is equal to 4 years and 3 months. I'm just going to type it in. It's 3 divided by 12. All right. It says it's compounded quarterly, which means the n is equal to 4. And what do I want to do? I want to solve an equation now. Solve. And what do I want to solve? An equation A. Oh, you know what? Did I define my variable? My variable is what in this case? Let's see, I got A, P, T, and N. I don't know what R is. So I did that last time too. I didn't define my variable. So I'm going to say R is of R. And now I'm going to solve. Let's see if it can do it. Solve A equal P star 1 plus R divided by N raised to the power N star T. And we're going to solve for the letter R. Let's see what happens. Wow, I don't want that. That's crazy looking, isn't it? So what I do is I'm going to clear the screen. Don't be alarmed by that. And what I want to do is solve the equation. And I'm going to do it by looking at the equation. So I'm going to say, and I'm actually going to solve it now. So 4, 3, I'm doing the algebra. 7, 8, divide by 3,700. And that would equal that thing raised to the power. But now I got to take the log of both sides. And I'll put this over here for you. I'm going to say log. And you can use paper and pencil if you want as well to help you out with what I'm typing in over here. And then what would I get? Well, remember, if I took 4378 divided by 3,700 and took log of both sides, I'd have now a coefficient, right? It's tough, though. I'm not saying it's easy. I'm going to divide by the coefficient. What's the coefficient going to be? Well, it's going to be dividing by 4, and I'm going to divide by 4.25. All right? Now someone says, what is that going to equal? That's going to equal a log of 1 plus R over 4. So now I got to take the anti-log, which is going to be e raised to a power. It's a lot of work, though. I know that. E raised to this power over here. And then what I'm going to do, it's going to be equal to 1 plus R over 4. Well, I'm going to subtract 1 from it. And then I'm going to multiply it by 4. So let me go back over here. Yeah, I know this is difficult. Probably easier to do on paper. And I'm going to multiply it by 4. Now, you might be surprised what happens now. I certainly get an answer. What's the answer? I just solved for R. I used a computer to do it, by the way. And someone says, what is that number? It's R. It's the rate, right? That's the rate. Now, certainly, I want to report the rate as a percent. So I need to take the number. This is the underscore means the prior output, and multiply that by 100 to get the percent. And what's that going to be? You know, it's approximately 4%. Now, certainly when I say that, you could do more precise than that, but approximately 4%. And that's a fine answer, approximately 4% interest. This was more difficult using a computer, by the way. However, no matter what you do, you're going to have to learn how to use a computer to solve these things. I really think back to Wells's error, how difficult problems like this were to solve. I mean, it was tremendous effort in the arithmetic department, including using log tables, anti-log tables. It was tough. Thank you.